If you've ever dealt with duplicate data, broken spreadsheet, or confusing tables, you've already experienced why normalization matters. Today, we will fix that by designing a real M-Pesa style database from scratch and applying the first normal form, second normal form, and third normal form in a practical way. Okay, so let's get started. So in this session, we shall going to learn more about normalization. So we shall going to understand why normalization is very important. We shall going to identify problem in a large table. We shall going to apply the first normal form, second normal form, and third normal form, and then later on design a cleaner database structure. So first of all, let's understand what is normalization. So normalization basically is the process of organizing data into a separate table to reduce duplication and improve data integrity. So in general terms, normalization is basically when you have a large table and you want so you have a large table and you break this large table into smaller and smaller tables so that you can reduce data redundancy and improve data integrity. So there's different forms of normalization, but in this session we shall only going to deal with 3 forms of data normalization. So let's start with the first one, which is first normal form. So first normal form, it has a rule here. So this is the rule of first normal form, where each cell should contain a single value. Each cell should contain a single value. So let's practically see how this is applicable in the how we can practically apply this. So you can see here we have a table which contain customer ID, customer name, customer phone, transaction ID, date, agent ID, agent name, agent town, and item. But if you look at all these values, you can see each and every value is in its unique cell except the items. You can see, for example, sugar 2 kg, this is an item, and then 250 is the price of the sugar, and then 1 is the quantity. So you can see like this column, there's 3 things here that were combined. First we have the item, and then we have the unit price of the item, and then we have the quantity. So these are 3 things that were combined in the same cell. And also we have a cooking oil here, the same. We have the cooking oil being the item name, and then we have 350 being the unit price, and then we have the 2 being the quantity. And from the rule of the first normal form, it states that each and every cell should contain a single value. So that means we need to put these things that have been combined into one cell into each should be put into their respective cells. So let's just put it so let's copy this and then we apply the first normal. So let's copy here. Yeah. Yes, so here we'll have to separate these combined item into their respective items. So that means we will have to add another column here for the unit price. So the item price, item price, and another column for quantity. So this one you can just call it maybe item name. So we will going to separate these things into their respective cells. So let's start with the sugar 2 kg. This is a unit, this is an item name, so it will just remain in this cell. And then 250 is a item price, so we shall going to put it 250 here. And then here we have quantity. Quantity is 1. So we are done with this one here. We are done with so we are done with this. So now let's also separate this cooking oil from all these other items. So for that we'll have to add another row here. So I'll just click on insert, and then you shall going to copy the whole of this, copy, and then we paste here. So here we will only going to leave, the cooking oil. So remove this sugar kg. So unit price of cooking oil is 350, and quantity is 2. So remove this 350. Also remove this, we only remain with the sugar. And then here we have here also we have bread here. So bread is the item name, and then 60 is the unit price. So 60 here, and then quantity is 3. So let's remove this. Yes, so you can see we have each and every value settled in its own cell, where you can see customer ID, customer name, phone, customer phone, transaction ID, dates. So everything is now settled into their respective cell. So that means it satisfies the first normal form. So now let's move to second normal form. So second normal form, first of all, it must be in the first normal form. Second normal form, first of all, it must be in the first normal form. So that means we cannot take this original table, which is not in first normal form, and start applying the second normal form. So the second normal form, it must be the first normal form. So let's copy this, and then we take it to second normal form. Second normal form, yeah. Yeah. So also second normal form, all non-key attributes or column must fully dependent on candidate key. So first of all, we need to understand what is this non-key attributes and what is this candidate key. So candidate key here is a set of columns which uniquely identify a record, while non-key columns, these are columns which are not part of the candidate or primary key. So here we have so here we need to identify the candidate key, because if you look at this data, you can see like we don't have any column that can have unique values. We don't have any column with unique values. So in that situation, you normally choose two columns and combine them so that they can give you unique values in each and every record or in each and every row. So for that, customer ID, if we combine customer ID and customer name, these two, they will give us a candidate key, or what we call, or also called composite primary key. So our candidate key will come from transaction ID plus item name. So since we now know the candidate key, now let's go back. All non-key attributes or column must fully dependent on the candidate key. All non-key attributes. So that means these are the keys that we have combined so that they can give us the candidate key. So the rest are non-key values. So we only have the transactional ID and the item name. These are the keys. So these two keys, when we combine them, they give us candidate key. The rest of the column will be non-key values. So, and the rule here is all non-key values, or all non-key columns must fully depend on the candidate key. So if you look at all these non-key values, some of them will not depend on candidate key. So some will depend on, so let's use so here we have the candidate key which comprises of the transactional ID plus the item name. So here from this combination, we shall going to generate three tables. The first table will contain the candidate key plus then none plus then none. Let's just yeah, so the first table will contain candidate key, candidates key candidate key plus the non key columns depending on the candidate's key. Candidate key. So this is the first table, and then another table we shall going to get it by candidate by this transaction ID, one of the keys, transaction ID plus the non keys depending on transaction ID. Transaction ID. And this other table will be this one, will come from now this where it will come from the transaction, the item name plus the non key columns depending on item name. So this table, it will going to be splitted based on the dependency. We have some non-key columns that will depend on both of the two candidates. We have some non-key columns that will depend on only the transaction ID, and we have some non-key columns that will depend on item name. So let's now explore each and every non-key values to check whether they depend on candidate key or depend on transaction ID or depend on item name. So if you look at this table, you will find that customer name, like the customer details in general and the agent details, they depend on transaction ID. So you don't need to know which item was brought to know which the customer was and which agent processed it. So like by just having a transaction ID, we can be able to know the customer details and the agent details, because each and every transaction was done by a single customer. and each and every transaction was processed by a single agent. So therefore, we have customer ID, customer name, customer phone. So in that case, so now let's start splitting this, where from our explanation here, so we've started with this one where we have transaction ID plus the non-key values depending on. So let's have this where we shall going to have transaction ID here plus the non-key values depending on this. Non-key values such as customer details and also agent details. So let's yeah. Yeah, so we have this one as we have this table. So this table we can call it transaction. Transaction. So let's give it so transaction, and then also so we are done with this one, where we have explored the non-key columns like the customer ID, customer name, phone number, and then dates, and then agent ID, agent name, and then we have this another non-key value, which is item price. So item price depends on item name. So item price, this one depends on item name. So a product price is the same regardless of the transaction. So that means the item price depends on this item name. So we shall going to build another table. So let's just call it item. Now let's call it let's make it green. Yeah, and then so we shall going to pick this and this, copy, and then we paste here. So we have transaction, we have item. So we have done this and we have done this. Now let's continue exploring the remaining non-key values or non-key columns. So we have this quantity. Remain as one as the non-key columns. So quantity, if you look at quantity is the one that depends on both of the transaction and item name. We cannot get quantity unless so we cannot so quantity is the one that depends on the candidate key, which comprises of the transaction and item name. So we need to specify the transaction ID and the item of that particular transaction, so that that's when we can now get the quantity. It's like a student marks. For us to specify marks of a specific student, first of all we need a student number and the cause of that marks. So student and course ID, this one will all of them form the candidate key. So for our case here, we have transaction and item name. So so all these, they form candidate key, and we cannot, and quantity depends on both of these two things, the transaction ID and the, so that means we shall going to have this copy here, and this copy here, and the quantity and the quantity and the quantity. So let's call this one this one, since it's combination of transaction and item, so we can just call it transaction item table. Transaction items, something like that. And then we yeah. Yeah, so we have how many tables? Okay. Yeah, so we have how many table? We have the transaction, we have the item, and we have the transaction item table. So from this large table, we have divided it into three smaller table based on these key items here, based on these three key key columns or key values and the non-key values, where we have some non-key columns here, which they will partly depend on the candidate key. So that means some of them they will depend on transaction ID, and some of them they will depend on item name, and some of them they will depend on both of these. So you'll eventually end up having these three tables. So we are done with the second normal form. Now let's move to the third normal form. So the third normal form here, so where's the rule? So we are also done with this. Yeah. So let's go to the third normal form. So it must be in second normal form. First of all, it must be in second normal form and avoid transitive dependency. So let's find what is transitive dependency. So transitive dependency means no non-key attributes should depend on another key attributes. So let's check on these tables here, especially on this transaction table. If you look at transaction table, you will find like columns like customer name. They don't depend on this. They don't depend on the transaction ID. Remember, transaction ID is our main key. So we expect all these non-key values should depend on this, but we have some non-key values who do not directly depend on this. For example, customer and customer phone here, they depend on customer ID, not transactional ID direct. So this one, they depend directly on customer ID, not this one, the transactional ID. So that means we will also have to split this. So it's more of like it's more of like, now we have, so we have transaction ID here, and then we have customer ID, and then we have these non-key values depending on customer ID. So that is customer name, that is customer name, and also customer phone of customer. So this, they depend directly to this. They depend on customer ID, and indirectly to this. So they generally depend directly to this and indirectly to this. So that means we will have to separate these non-key values that do not directly depend on the main key values. So we're going to have another table which will have the customer ID plus customer ID plus the non-key values depending on it direct, plus non-key non-key columns, non-key columns depending on its direct. Yeah, so this one will create another table, and then let's go back to the same table. Also the same table, if you look at the if you look at the agent name and agent town, they don't depend on transaction ID direct. They depend on agent ID. So we're also going to have another table. So let's just agent ID, and then here we have the agent name, stroke agent town, So these, they depend on this one. They directly depend on this agent ID, but indirectly depend on the transaction ID. Yet we know the transaction ID is the main key. So we'll have also going to separate this, so that this, they can have their main key as agent ID, and also this, their main key will be the customer ID. So that means we're going to have another one here, table of agent ID plus the non-key values depending on it. Non-key columns depending on it. Yeah. So let's separate these tables where we shall going to. So let's just take the whole of this. So this is the second normal form. So let's just pick all of them. Copy. And then we take it to third normal form. Did we really? No. What really happens here? Yes, so let's copy the whole of second normal form. the whole of second normal form, that is copy, and then paste here. Yeah, so we have these here. They do not depend directly on our main key here, so they depend on this, so we'll have to separate this. Yeah, so let's separate them here, where let's copy this, copy, and then we put it here. And then we put it there. So this one we can call it. So this one we're going to remove this. Just clear content. So this one we're going to call it customer table, customer table. So let's label it as customer table. This is customer table. So we are remaining with this. Copy, put it here. So let's remove this. So we are remaining with, and also here we have another table where we said the agent name and the agent term, they depend on directly on agent ID. Also this one will have to remove it. So copy, and then you put it here. No, let's put it here. So this one we can call it agent, and then this one, customers, and then you remove this from here. Yeah, so we will finally going to have these 5 tables where we have transaction table, we have items, we have transaction item, and we have customers, and we have agent tables. I think you've enjoyed this session.